Good afternoon, everyone, and welcome to today's webinar, Palletized Product Freezing, How to Save Your Warehouse Money, Time, and Energy, brought to us by FPSA member Tipman Innovation. Our speaker today is Dan Tipman. Dan is the owner and principal officer. My name is Dolores Alonzo, and I'm the VP of Membership here at FPSA. This webinar is being recorded, so for those of you that are FPSA members, let your colleagues who are unable to listen to it live today know that they have access to it in the members only section of the FPSA website. And for those of you who are not FPSA members, just shoot me an email and I'm happy to provide you a link to it. My information can be found on the FPSA website. Before I pass this over to Dan, just a few housekeeping items for today. All attendees are muted by default, but you'll have the opportunity to submit text questions to Dan today by typing in your questions in the questions pane of the control panel. You may send in your questions at any time during the presentation and we'll address them at the end. So thank you everyone for joining us this afternoon. Let's go ahead and get started. Give me 2 seconds to pass the controls over to Dan so he can begin. Dan, are you all set?
Yes, Dolores.
Thank you very much.
We
We appreciate the opportunity to present this webinar, and we'll jump right in. I'm going to start out with a little bit of history related to palletized product freezing. Then I'll talk about what I perceive as the limitations, and then I'll describe some of the development of the QF Plus in-rack freezing system. And we'll talk about kind of the progression when people are interested in the technology, how it progresses from interest to validation to installation. We'll show you some installation photos, and then near the end we have a short 4-minute video, and then we'll open it up to question and answers. So just a little bit about us. We're Tipman Innovation. We're focused on the temperature-controlled facility market. And when we're going to focus on what I call the traditional blast cell. Most of these were designed by either refrigeration contractors or by plant personnel that had experience with the movement of air and freezing a product. So many of these have, they all have very similar parts and pieces. Some of the details of construction are different, but this is basically how they're set up. There's a room, which there's typically panel walls or some type of enclosure. There's a dedicated evaporator above what I'm going to call a false deck that enables the airflow to be routed out of the evaporator, out over the top of that deck, across the product, and then returning to the return side of the evaporator. One variation of this is if you turn the evaporator 90 degrees and the air went side to side, but still there is an established airflow pattern in the cell to help liberate the heat from the product and be the driving force of air through the evaporator. Now, we were always taught the air tends to follow the path of least resistance. Now we're going to use this to take a second look at the conventional blast cell. When we use the path of least resistance and we consider this graphical representation is the front of that conventional blast cell. We're going to zoom in on this one yellowed out section to show you the challenges of getting air through the spacer area of the product. So if you consider the rectangle, the yellow rectangular area, in this example is approximately 22 square feet. The cases comprise a little over 8 square feet. The spacer area, the space between the cases, that is only 11% of the available area for air to flow. And the bypass area, which air going across the top, going left or right of the stack through the open part of the pallet, that comprises 8 square feet, or 37%. So when we consider the path of least resistance, the air is associated with this pallet is going to be more motivated to pass over and around the product rather than flow through the centermost sections of the pallet. Now, when we consider this conventional blast cell, and we look at our single pallet problem, now consider when you put multiple pallets in series. So now the air not only has to try to get through the spacer area, it's going to try to get through multiple rows of product. So in this example, where the air is moving front to back, the air has to pass through 6 pallets of product before it can get to the return side of the evaporator. If it's going in the other way from right to left, it has to pass through 4 rows. So the pallet represents a significant amount of air side resistance, and we are placing multiple pallets in the airflow pathway. So now when we step back and look, we say it would be great if we could devise a freezing system that targets the air to move through the spacer area, the area between the layers of cases. If we could do that exclusively, we wouldn't have bypass air going around our product not doing any work. So that was the goal with the induced draft in-rack freezing system that led us to the QF Plus. And the development went like this. So let's just look at one pallet, and if we wanted to establish an airflow pattern where the air came from the area around the pallet exclusively through the spacers and then out, we could put a dedicated fan up adjacent to one side of that pallet. And when we turn the fan on, we're going to be discharging air out the right side of that fan. And at the same time, we would be inducing flow through the spacer area. So we are pulling air through the pallet. So the blue arrows represent the air entering the spacer area, grabbing the heat from the case product, and then it gets discharged out to the right. Now, rather than have one pallet in a freezer with one dedicated fan, the intent was to get that same airflow arrangement, but have it in an array, the ability to have several pallets across and several pallets high, so we can not capitalize all the floor space in a warehouse. So that really led to the in-rack version of that single deep pallet airflow arrangement I showed you in the slide before. So this arrangement enables us to mimic that same single deep excellent airflow through the spacer area, but do it on a much larger scale. So rather than having a single dedicated fan for every pallet, we allow the pallet to be exposed to an opening that is much like that fan opening in the slide. And then on the other side of the opening is a plenum, or a space where air can flow in. And we have an array of direct drive propeller fans exhausting air out of that plenum. So we are inducing flow through the spacer area of that array of pallets, grabbing the heat from those cases and discharging it vertically up and into the room. So here's kind of what it looks like after installation. We use exclusively structural steel racking. And if you look, this is a back-to-back arrangement. So there's freezer or freezing locations on this side of the rack and freezing locations on the opposite side of the plenum. So in this arrangement, we want the only openings into the plenum space to be these rectangular openings that are going to be filled with palletized product. So we want the pallet to be centered on that opening. So on the floor, we provide guides that are fastened to the floor, both left and right of the pallet, to enable the operator to place the pallet in the center of the opening. If you look at the back is an actual stop. We call this a pallet stop. And the product is loaded up so the pallet engages that stop. And if you remember the graph that showed the air that was able to pass through pallets, in this arrangement, we're actually blocking that space with that pallet stop on the back. So that pallet stop is the height of a pallet. Then we block off with fixed blocker panels left and right. And then this panel up above is our variable height swing seal. This swing seal enables us to load variations of pallet heights into the same location. So we can load product as short as this bottom edge of this swing seal, and we will get some deflection of that gate inward. And notice no air can pass over the top of the pallet. Then we can also load a much taller pallet, like up at this level, and we would just be deflecting that gate inward more degrees, and it would still open up the airflow pathways for the spacers, but prevent bypass air from passing over the top of the pallet. And I explained the floor guides. In the positions above the floor, the second level locations and up, we provide a drop-in pallet guide that enables the operator to place the pallet onto the edge of the guide and then push it back into the location until it engages the opening. And then obviously between these is our reduced pressure plenum, where we have exhaust fans at the top of this arrangement, and it will be inducing flow through the pallets and then up and out the top of the plenum. Here's what the operation of the swing seal looks like from inside the plenum. I apologize for the challenging photo quality, but it pretty much shows us how this works. So this box product that's outside, it's approximately at this level. So when that product was loaded, it deflects that gate inward and exposes the spacer areas and prevents bypass air from going across the top. So notice it pivots about a rod located near the top of that swing gate. Here's what it looks like from outside or from the aisle. So you can have product that is much taller sitting beside product that's significantly shorter, and we are utilizing the same height opening. It gives you a lot of operational flexibility to load a variation in pallet heights into this system. Next, as we began freezing faster and faster compared to conventional blast cells, it really became apparent that spacer technology was hurting the performance. So I'm going to skip one slide. If you notice, the accumulated weight on the picture on the left, the palletized product, the accumulated weight of the cases tends to crush the space between the lower levels. So there's significant space on the upper rows of product, but the further down you get, the more compressed those spaces become. And in this example, it's exaggerated, but it's very real that the spacer was definitely preventing adequate airflow between the rows of cases to get the work done. So that really drove the development of a spacer that, number one, very much helps carry the weight of the product. So it gives the corrugated box a chance to succeed. So we're carrying a lot more area than a conventional spacer, and we get the excellent flow front to back on the spacer to be able to get the air through the inner parts of the pallet and into the plenum. So if you look, the photo on the left is, I call this a maxi spacer. It's a very tall spacer, and it was definitely needed. And if you look at the very bottom, it was virtually cutting off its own air supply. Yet at the top, there's probably 2 inches of space in the cases. The same product on the right, notice we're carrying the cases much better. The accumulated weight is not cutting off the airflow pathways for those cases, and we get much better freeze results. So this is one of the high turn products in the poultry industry. These are 10 kilogram leg quarters. This product was reaching a 0-degree core temperature in approximately 16 hours. And it was really a function of the QF Plus system, the T2 spacer, and the experience of the operator. So it's just a very good demonstration of the capabilities of the system. So here's how the typical operation works. Someone expresses interest in this technology, yet they don't know whether it's going to be a good fit for their product and their process. So we will deliver what we call a demo unit that is a single pallet system that mimics the performance of the full-scale system. So if you notice, there's the swing gate at the top of this unit. There's a dedicated fan, and we're able to place the spaced, cased product up against that demo unit. And that single fan that's in here mimics the flow that you're going to see in a single pallet position on the full-scale system. Then we normally encourage the user to also put time temperature data recorders in both the QF Plus demo unit pallet and a control pallet. So if they're room freezing it, we put it in the room freeze pallet. If they're using a conventional blast cell, we'll want it into the conventional blast cell. So we want to be able to compare the freezing system. Number one, make sure that the technology is a good fit for the customer. And number two, we can show the delta in performance between what they're doing currently and our solution. With the demo unit, we ship a data collection packet. So we will deploy these time temperature data recorders in multiple places in the pallet, and then deliver a performance report where graphically it'll show the performance of the system and just provide the owner or whoever's demoing the unit to see some good data on their product. The next thing we do is this comparison was developed for one of the big PRW companies, and they really wanted to wrap their heads around the total cost of ownership. So they wanted to know a comparison on the potential operating cost differential, And then the next slide is going to show an installed cost differential. So in this example, we're going to compare, based on test results, we knew that we could do the freezing work utilizing 400 QF plus positions versus I think it was 590 conventional blast cell positions. So on the left-hand side is a cost associated with handling of the product. So the QF plus system being a single deep select rack, our pallet handling rate is very good. In this example, it's 60 pallets per hour versus a 25 pallets per hour in a drive-in multi-row deep conventional blast cell. Then on the right-hand side, we show a refrigeration comparison. This company utilized a minus 40 degree suction temperature or a minus 30 blast cell temperature to get this work done. And our system was able to do this, was able to turn the product and operate with a minus 20 saturated suction temperature or a minus 10 degree room. So we're freezing the same amount of pounds per day, so our total refrigeration capacity is the same. However, our operating costs, if you notice in this example, the cost per pallet for the conventional was $6.74 versus $4.79. In the lower left-hand side, we show the total cost per pallet. And in this example, it was $9.22 a pallet. Conventional, $5.82 per pallet using QF. The next slide is comparing the installed cost. So with our solution, we have our QF Plus system. There's electrical, we have to run power to fans, and then we have the refrigeration capacity required to support our system at our temperature. So in this example, our solution for these 400 pallet positions was $4.23 million. Utilizing this information from the customer, they knew their costs for all the parts and pieces it took them to put their conventional blast cell together and the cost for the refrigeration to support that. And in this example, they're just over $6 million. So there was a pretty good differential in installed costs. The other thing we do, so if things make sense, people say, yeah, it works well for my product, I have space for it in my operation, we can help lay out the QF Plus solution in your facility. So we look at how much height do we have available, and then we show people what it looks like in the plan view. So from above, we show the width needed. We make sure it works with their aisles. And if you notice, on the far left-hand side, this is a single deep arrangement that could be placed against an outside wall, for example. So we have product being loaded in from the aisle up against a plenum, and then we have our fans exhausting air out the top of the plenum. The next part is a back-to-back arrangement like the photos we saw earlier. And then here's what it looks like in elevation view. So we'll work with customers to show what an arrangement could look like within a facility. And we've worked with people on both the freezing area, a D-space area, wrapping area, on many high turn, high volume operations. The typical flow is from the refrigerated dock into the freezing area and then into a D-space and then wrap area. The other thing we look at, once we know the available height and the height of the stack of product. We can just do a quick calculator, make sure that we're getting, we're taking advantage of the full height capabilities of the space and getting the best utilization of the footprint of the facility. So we just have a quick rec calculator. Another thing we offer is a maintenance program. And at the time of commissioning, we will do validation testing with the customer, help them to know how to develop the protocols for different products. And then with a maintenance program, we would come in like on an annual basis, inspect for any damage, anything bent, broken, missing, debris, stretch wrap, things can get into the system that really need removed. And then we finish that maintenance inspection with another validation test, and we will compare that to the initial system test. Here's a couple installation photos. This one happens to be a high volume poultry operation, and there's evaporators in the room. So if you notice the array of fans they're direct drive propeller fans, and they're exhausting vertically upward. So we get air flowing from the aisle through the product into the plenum and out. Here's a single deep against a panel wall. So again, we have the direct drive propeller fan inducing flow, so we're able to pull air through the product and up and out. This is a good slide to talk about maintenance. If you consider the direct drive propeller fan arrangement, it's very akin to the direct drive propeller fans that are in evaporators in industrial applications. So they require virtually no ongoing maintenance. There's no belts or bearings or shafts or anything that needs ongoing maintenance. It's really just a direct drive motor. So it's a very, very low maintenance system. Here's just a view from the floor looking up. So we can approach the clear height of the building, typically up to about 8 inches from the bottom of the joist. So the air discharging out the top, there's space typically within the joist space to discharge into. So we'll often work with the operators. So the people, like if they are stacking the product at the facility, we'll work with them on stack quality. Then we'll work with the material handling operators on how to load, unload, and determine whether things are loaded properly. So it's a comprehensive effort to get the most out of the system. So this is one of our training slides. We show on the left, we don't want a pallet that's so short. So this partial pallet was too short, and there's bypass air above it. This same pallet, we show how to remedy the short or the partial pallets. So they add a spacer and move some of the cases up and block off that space. So it's just a training slide that helps people succeed with the system. Another part of our business is tempering or thawing. So the same technology works very well. We're getting great velocity between the layers of cases, and in our freezing operation, we know that we're able to target the air through the centermost portion of the pallet and get great heat transfer. Well, the reverse can happen when in thawing operations. So it's very, very similar design. One thing we do offer with the quick thaw is all galvanized steel components. Notice these are powder-coated components, but we do offer all hot dip galvanized components. The swing gate is 304 grade stainless, but everything else would be hot dip galvanized. I'm going to run it's about a 4-minute video, and then after this we'll have a Q&A period.
As a cold storage provider, your services play a huge role in the industry and in the success of your customers. Your business needs to continually improve technology and incorporate lean principles to ensure more revenue, increased efficiency, capacity, consistency, product integrity, and safety. QF Plus is an innovative, patented design that induces the flow of air directly through the core of the pallet while the pallet is safely stored in the warehouse racking. In-rack freezing is the fastest way to freeze palletized products, and it is a game changer for the cold chain. We've been problem solvers in refrigeration and cold storage for over 50 years, so we have designed our innovative technology for you to maintain your competitive edge and best serve your customers. Our systems freeze over 7 million pounds of product daily, which is why our customers trust us with their performance, consistency, and product turns. If you think about food safety, when you make a decision that you have a product that's being stored at a refrigerated state and they want to have it frozen, you need to get it there as fast as you can. Time is, of the essence. So what the QF Plus system, what it allows us to do is get through that cycle faster than the traditional cells that we work with at West Liberty Foods and Liberty Cold. So for us, knowing that we have a system that we can go take a pallet of product, do testing, and time again beat the traditional cell, when you're kind of looking to go, this is a win-win from a food safety standpoint, and it's helping our business and our customers have better quality product, and so it makes a lot of sense.
Well, when they first brought the demo here, I did shake my head a lot. I was totally a disbeliever. I've come from using multiple glass cells at multiple companies in my 29 years of doing this with major food companies, and it just didn't make sense to me. It was just too easy. It took me a few lows in and out to become a believer. The simplicity of being able to find a pallet in a cell, any pallet that you wanted, being able to freeze stuff, blast freeze stuff, to minus 10 degrees in less than 48 hours. And our turn times have just increased 3 times. It's just, I'm a believer for that way.
QF Plus is the fastest way to freeze palletized products for 3 reasons. Number 1, air is laser targeted to the areas needed. When the air is forced to the center of the pallet, every case on the pallet freezes at the same rate, rather than waiting for the slowest case to freeze before removal from a conventional blast zone. Number 2, consistent results. When you can depend on your system to do the very same thing every time, you can pull the product precisely when it's ready. This cuts out the contingency time that is needed to safely freeze with blast cells. Number 3, logistics. The greatest operational benefits of in-rack freezing is the labor savings. Switching from a batch process to a continuous operation will net savings of 2 hours per cycle and reduce manpower requirements. If you have a varied SKU mix, you can freeze product with variable dwell times and further increase your freezing capacity. Your reputation and revenue is built on quality and speed. QF Plus delivers both.
Okay, that's really the end of our presentation. We feel like this is a great solution in most palletized freezing operations, and we feel confident it delivers the best value for the user, and it very very well freezes repeatedly, so you get very consistent results. So thank you very much, and if there's questions, hopefully I can take a few minutes and field those.
Terrific. Thank you, Dan. Yeah, we've got 2 questions here. The first is, with traditional blast cells, we turn the cells on and off while moving product in and out. With your system, are you able to keep the system running while moving product in and out?
Yes, we are, and that's a significant departure. The question related to when you try to go into a conventional blast cell, remember that the airflow pattern that's trying to be established, that would be extremely uncomfortable to expect someone to operate equipment in there. But when you consider, really, our velocity is targeted at the center of the pallet, so we're inducing air from the aisle through the product. That's where we get the great velocity through the product. We're away just a few inches away from the product, the velocity drops to a very comfortable condition. So it's very different, and it's very workable for the operators.
Okay, great. Thank you. And the next question is, what is the recommended temperature of the room during the freezing process?
Well, what we typically tell people, it really depends on the speed, what kind of turns you're wanting, which that will be determined during testing. But a good rule of thumb is we'd like to see approximately 10 degrees lower room temperature versus the target temperature of the product. So if you want a 0 degree target core temperature, a good rule of thumb would be a minus 10 degree room temperature.
Okay, very good. Thank you. Well, that's all the questions we have. We just want to thank everyone on the behalf of the FPSA and Tippmann Innovation for taking some time out this afternoon. You have Matt and Dan's contact information if you'd like to reach out to them directly. So once again, Dan, thank you very much, and thank you to all of our attendees. Have a good afternoon.
Thank you. Take care.